Okay, so last time we talked about how to tell if something was a function or not. So if something is a function, we have a special notation, right? It's function notation. And here's what it is. So I can replace the y, if it's a function, with f of x. So that's read f of x, right? It's not f times x, it's special notation, right? Read f of x. Okay, so anytime I see an equation that's solved for y, that has a y in it, if I can determine it to be a function, I can replace the y with f of x. More importantly, anytime I have an f of x, I can replace it with y. So I want to kind of remember that when I'm graphing, because on my graphing, I like to see my x's and y's. So f of x just is y. F of x is y. F of x is y. Okay, and it helps us, it's just kind of a shorthand to help us for evaluating functions, which we'll look at in the next slide. For example, if we have this equation y equals 3x minus 5, and we know it's a function, and because it's a line, right? I can tell that I can't cross it more. Think about what the graph looks like. I would not be able to draw a vertical line and cross it more than one time, except for one kind of line, and that is if it's a vertical line. But that wouldn't have an x and a y. Okay, so I can just rewrite it. Instead of y equals 3x minus 5, f of x equals 3x minus 5. Okay, just another name for y. Okay, and one reason that it's so useful is that if I had this equation, y equals 6x minus 2, and I wanted to find out what y equaled when x was negative 3, I'd have to say all of that. But if I use function notation, I can just say, find f of negative 3. Okay, f of negative 3. That means everywhere there's an x, I'm going to put a negative 3. So f of negative 3 is 6 times negative 3 minus 2, or negative 18 minus 2, or negative 20. So if I were to use my function notation, it tells me a whole bunch of stuff. Okay, it tells me, oh, this means when x, because it's f of x, f of x. This tells me when x is negative 3, y, f of x, the entire thing is y, is negative 20. All right, so let's evaluate this function when x is 0. I could have simply said, find f of 0. That simply means plug in a 0 everywhere there's an x. So 0 minus 2 is negative 2. So when x is 0, y is negative 2. F of x is negative 2 when x is 0. Okay, so now they're using it in that notation instead of saying let x be negative 3. Okay, so we're just going to find f of negative 3. So everywhere there's an x, let's replace it with a negative 3. Be careful of your signs. That negative has nothing to do with this x squared, right? Remember our exponent rules. So if I want x to be negative 3, that would look like that. Plus 3 times negative 3 plus 3. So this is, here's negative 3 times negative 3. So that's positive 9, negative 9. Minus 9 plus 3. Okay, negative 18 plus 3, negative 15. So f of negative 3 equals negative 15. I can also evaluate a function for another variable or another expression. Okay, so just replace every x with t. Or it could have just as well have been t minus 1. And then simplify, don't forget. Okay, like this one. So here's g of x, and by the way, if you have more than one function, you could call it 1f, 1g, 1h, okay? So it doesn't have to be f of x. So you might see g of x, but I just got to recognize what this notation means. Find and simplify g of t plus 2. So into the function g, everywhere there's an x, I'm going to put t plus 2. So 5. Instead of x, though, let's change it to t plus 2 minus 1. 5x minus 1. And then simplify. So let's distribute that 5. 5t plus 10 minus 1. And now I can combine these like terms. So g of t plus 2 is 5t plus 9. Okay, find f of 2 for each function. So here we've got the function as a couple of points. So f of 2, well, here's 2. So when x is 2, y is 6. Right? Here, if it's like this, we've already practiced this a couple of times, negative 2 squared. Now remember, that negative has nothing to do with that exponent. If it did, it would look like this, right? So that negative stays, and then the 2 squared. So f of 2 is negative 4. Okay, what if, and it's a function, we can tell because it passes the vertical line test. What if we have a graph and it says find f of 2? Okay, well here's, remember, it's f of x. F of x is the notation, f of x. So that 2 just means, oh, x is 2. So here it is. Let's go up and find the y value when x is 2. F of 2 equals 1. When x is 2, y is 1. Okay, f of negative 2. F of x, f of x. So when x is negative 2, what is y? Y is, poorly drawn line, I believe. So we'll just call this, what do you want to say, 2.9, 2.8? So f of negative 2 is, we'll say 2.8. Right? When x is negative 2, y is, and remember, f of x is y. F of x is y. Okay. For what value of x is f of x equals 0? Remember, f of x is y. F of x is y. So for what value of x is y 0? Okay. So y is 0 right here. Right? So x is 4. Y is 0. Remember, f of x is y. F of x is y. Okay, given the function, give the domain and range. Well, let's graph it. And if we're graphing, I like to see my x and y. I like to replace that f of x with y, whatever you prefer. So let's draw a graph of this. Okay, since it's set up for the, and that's another thing about function notation, it's always already solved for y to use this notation. So it'll be set up nicely to graph with the slope and intercept. So the y-intercept is 3. The slope is negative 2 over 1. So down 2 over 1. Or it could go up 2 and backwards 1. Okay. Okay, so there's a graph of the function. The domain is the x values. So if I'm looking across here, oh, the first thing I come to is an arrow. It's not only going up forever, remember, but it's slightly going this way, this way, this way, this way forever. So negative infinity, because I'm talking about the x's, so it's going this way forever, all the way to, oh, an arrow again, so it's gradually going this way forever. And the range is the same thing, because you've got arrows going up and down forever, right? Arrow, arrow. Okay, same thing. If I need to graph that, I want to change that f of x to y. Oh, and hopefully I recognize, hey, what happened to my x? If I don't have an x, I only have one letter. It's one of those special ones. Okay, since it's y, here's my y-axis. There's the tick mark for y equals negative 1.5. That tells me the special line is a horizontal line. The domain is negative infinity to infinity, because you got arrows going all the way to infinity, all the way to negative infinity. But the range is negative 1.5. Now, it's not an interval, so I'm going to put it in braces because it's a value in the set, right? It doesn't ever, y is just negative 1.5 always. So that's my whole range. It doesn't vary. One more. Okay, again, if it makes a difference to you, you can change that function notation to a y. And then I see that my y-intercept is negative 2. I've got a slope of 1 over 3, so up 1 over 1, 2, 3. Could go down 1 or backwards 1, 2, 3. Either way. There's my graph. Hopefully it's a straight line. We're going to imagine that's a straight line. Okay, so the domain, oh yeah, look at this, negative infinity to infinity. And the range, negative infinity to infinity. Every line that's not completely horizontal or completely vertical is going to have the same domain and range of negative infinity to infinity if it's a line that's not horizontal or vertical, right? Okay, let me know how it goes.